Question number 5 is another word problem. And the thing that we have to know going into these word problems is that it's very difficult to tell what kind of problem we have. We don't know if it's arithmetic or geometric. We don't know what the pattern is. So the first thing that we should always do when we have problems that feature words is to just read and highlight any keywords that look like numbers so that we can interpret them and see if that gives us a hint about what sort of pattern we're dealing with. If we read about this one, it says that we have these people saving the same amount of money each week in a jar that they've set aside for vacation. Even though I'm not really sure what this pattern is, the fact that they're saving the same amount of money each week is kind of important. So I'm just going to highlight that just so I can see that and remind myself. After 2 weeks of saving, they have $17 in the jar. Now you'll notice I'm using different colors, and I'll mention why in a second, but those are numbers, so those jumped out to me. After 4 weeks of saving, they have $29 in the jar. Did you notice the pattern of my color coding here? Because I was trying to be deliberate about my color choices. I highlighted week numbers in pink and dollar numbers in green, figuring those are maybe like terms and those might have something to do with each other. Now, the first question says, how much did they have in the jar initially? And I realized they didn't tell me this information. So now we might be looking for a strategy. How would we know how much they had in the jar initially? You'll notice I just used some scratch paper here in my workspace because I want to organize my information. And as you've seen me do so many times before, I think the best way to organize my information personally is to use a table. I like tables because it helps me see everything and keep it straight. So I'm going to call n the number of weeks because usually n is a number of time. And then t of n will be the number of dollars. So n will be weeks and t of n will be dollars. If you mix this up, it's not really a deal breaker. You can always kind of figure it out. But generally, it's wise to use n as your time and whatever the other unit is, so in this case, dollars, make that t of n. So they didn't give me enough information to fill in a lot of the table. I know that after 2 weeks, we have $17. So notice I put that pair of numbers in the table. And then after 4 weeks, we have $29. Now I've had to skip some stuff in the table because they didn't really tell me things like 3 weeks, for example. They didn't say anything about that. But they did say we're saving the same amount. So whatever number I added to the $17, I must have also added again to get to 29. So now you have a choice to make. If you need to figure out the pattern to this, you should think about one of 2 options right now. First, is it appealing to try to guess and check? Could you guess a number that you could add to 17 and then add again to get you to 29? Because if your brain's already spinning and you're like already mentally checking numbers, you're like, okay, add 10. 10 plus 17, that'd be 27, plus 10 is 37. Oops, that's too big. And then you can refine your guess. By the time I'm done with this sentence, you might have already landed on a number that you know that you would be adding so that the pattern works. If you don't want to guess, or if you just feel like you're bad at guessing, you have another option. And the other option is to go back to a previous page in your notes where we've done problems kind of like this before. It was on page 7, which was a whole lesson about arithmetic sequences, and these were my notes from the day that we made the video. When we had a situation like this one in the lesson on page 7, we actually at the time came up with a formula or a shortcut that we could use to help us find what we were calling the adder. The number that we're adding and the number that we're missing in this problem that represents the amount that the pattern changes by. That formula that we came up with, and I'm going to copy it onto my notes here, the formula for the adder was to subtract what we called the t of n numbers and divide by whatever we get when we subtract the n numbers. So this would be a good time to ask yourself, do we remember doing that? Because if we don't remember doing that, I would say this is a good time to pause this video, go back to page 7 in your packet, see if you did these questions, and try to refresh your memory on what that looked like. Because chances are, if it's been a while since you've done this page, you might not have even remembered that we did it, let alone how we did it. So this would be a good time, if needed, to pause and go back to page 7, make sure we understand. If you do feel like you understand and you remember this, then let's use this formula thing, because it looks like those are referring to stuff that we have in this table. T of n, we already labeled, that's the number of dollars. And n, we already have in the table, that's the number of weeks. We have that info. So when they say subtract, that implies that we would subtract the two numbers they gave us. You can subtract in either order, but it seems to make sense to do 29 minus 17, since 29 is bigger than 17. When it says subtract n, those are the top numbers in the table. I just need to go in the same order, because I'm being consistent. If I did 29 first, then 17, then to do a similar order, I would take 4 first, minus 2. And if I do that math, that's 29 minus 17 on top, that's 12. Divided by 4 minus 2 on the bottom, that's 2. And 12 divided by 2 is 6. And if you're asking yourself, well, what's the significance of the 6 then? 6 must be the adder. 6 must be the number that we were adding each week in the table. So let's check. Let's see if 6 actually makes sense. If I really do add 6, 17 plus 6 would be 23. And 23 plus 6 really is 29. So it does look like that's the pattern. It looks like the pattern is adding 6. Now that's great, but remember, I haven't answered question letter A yet. Question letter A says, how much did they have in the jar initially? And that is not 6. 6 is how much they're adding to the jar each week. So that information that I highlighted at the beginning of the problem, that's the amount of money they're adding each week that we were never told. But if I need to go backwards, I need to figure out what happened initially. Initially is what we call time 0, or the initial value. So if I know the second week was 17, I can predict backwards. They must have added 6 and gotten 17 as an answer, so they must have had $11 in week 1. And if I go backwards again, they must have added $6 to get the 11, so they must have had 5 to begin with. Let's check. 5 plus 6 is 11, 11 plus 6 is 17, 17 plus 6 is 23, 23 plus 6 is 29. Yep, that pattern makes sense. So now I can confirm that they must have had $5 initially, because that's the only number that would have made sense with the adder that we got. So take a look at it, make sure the idea makes sense before we go on to other questions. Does it make sense where the adder came from? If it does it remind you of anything? This would be a good opportunity to ask yourself, does this remind you of something that you learned from Algebra 1? Because back in the day in Algebra 1, we used to call things like this by a different name, but we were doing the same math. It was called slope. What you actually just did was finding the slope between 2 points. If you wouldn't have ever thought of it as slope, that's okay, but that is actually what's going on. You found the slope. The slope was 6. The slope is the change, and you use that slope to help you go backwards to find the initial value. Now in the next question, you should be able to hopefully use your equation, which we could write at this point, to answer B and C. They didn't give us an equation, but we have enough info to write one. Remember how, and again I'm going back to my notes on page 7, the equation for a sequence like this would look? You'd have T of n equals the initial value, I'm just copying my notes, plus the adder times n. And we just found all of this information. We know that the initial value is how much they started with initially, that's $5, plus the adder, which we just figured out from our pattern was 6 with the n. So if I have an equation, maybe now I can answer questions B and C without too much trouble. Give it a try. If you don't feel like you know how to use the equation well still, then in the next video, I'll make sure that we go over that too.